compounds. So before we proceed, let's first have here this mnemonic, which is your UWA-UCA. So actually, this stands for the NPNs arranged in order from highest to lowest concentration in the plasma. So we have, of course, yung most abundant na NPN in the plasma would be that of your urea, followed by the amino acids. Then we have the uric acid, creatinine, and ammonia. So just like your lipid and lipoprotein determination, we actually have your enzymatic and chemical methods for NPN measurement. Pero yung term na ginagamit for NPNs would be the direct and indirect assays. Again, we have the direct and indirect assays. Just remember that when we talk about of the direct assays, this actually refers to the chemical assays or the chemical method of measurement, whereas yung indirect assay, this refers to the enzymatic assays. First question under your NPNs. So the reagent used in the Jaffe method for creatinine contains letter A, your alkaline copper 2 sulfate, B, sodium nitroprusside and phenol, letter C, your saturated picric acid and sodium hydroxide, or letter D, your phosphotungstic acid. So in Jaffe reaction, which is of course involved in the direct assay for creatinine, we actually make use of your alkaline picric acid, or that is letter C, your saturated picric acid and sodium hydroxide. What about the reagents given here in the other choices? So for choice A, guys, yung alkaline copper 2 sulfate, this is a reagent utilized in the Urea test for protein determination. Again, if you remember, your alkaline copper 2 sulfate is associated with that of the Urea test for protein determination. What about yung choice B? So for choice B, we have there your sodium nitroprusside and phenol. This, on the other hand, are utilized for the determination of your ketones. Again, these two, your sodium nitroprusside together with your phenol, are utilized for the determination of your ketones, specifically that of your acetoacetic acid. Again, specifically that of your acetoacetic acid. And for choice D, we have here your phosphotungstic acid. So for phosphotungstic acid, this is involved with the direct assay for uric acid measurement. Again, this is involved for the determination of your uric acid. Okay, so Jaffe reaction, as what we all know, is the basis for the direct method or the chemical assay of creatinine determination. So what is Jaffe reaction? So this is actually represented by this reaction here, wherein creatinine is allowed to react with your alkaline picric acid. So we actually make use of your picric acid here, and yung action ni picric acid is actually at optimal if it is present in an alkaline na environment, which is why we add that of your sodium hydroxide. So creatinine plus alkaline picric acid will result to the formation of a red-orange chromogen. So this is the Jaffe reaction that we are talking about for your creatinine determination. However, there were interferences that would cause falsely elevated na creatinine. Why? Because your picric acid here is non-specific for creatinine, which means to say, in the presence of other substances, picric acid could react to these other substances, and that would lead to erroneous result for creatinine determination. So for example, we have here these substances which results to positive interferences, or meaning to say, they lead to falsely elevated creatinine level. So these substances include that of your acetoacetic acid and your acetone. So basically the ketones, they interfere with creatinine determination using your Jaffe reaction. Aside from that, we also have your ascorbate or your ascorbic acid, your glucose glutathione, and pyruvate, and cephalosphorines. Okay? So because of this problem, the basic Jaffe reaction has been modified. One of the modifications included the addition of adsorbents. Okay, so that's why we have here your Jaffe with adsorbent method. So what's the purpose of the adsorbent here? Nasa pangalan niya na, kapag sinabing adsorbent, it will adsorb other substances out of the sample. So that picric acid will only react with that of your creatinine. Okay, and there are two types of reagents that we could use as an adsorbent for Jaffe reaction in order to increase the specificity of our direct method. So we have here your Fuller's Earth reagent and also your Lloyd's reagent. So Fuller's Earth reagent is composed of your aluminum magnesium silicate. On the other hand, your Lloyd's reagent is composed of your sodium aluminum silicate. However, the disadvantage here is, of course, nagiging time-consuming yung ating method. Because, of course, aside from allowing your alkaline picric acid to react to creatinine, you would also have to give time for the adsorbent to fully remove the interfering substances. So in the next slide here, guys, we just have a summary for the chemical methods based on Jaffe reaction for creatinine measurement. Take note, guys, that your Jaffe with adsorbent and Jaffe without adsorbent could be both classified as what we call as the Jaffe endpoint reaction. Again, both of this could be classified or categorized as a Jaffe endpoint type of reaction. Why is it endpoint? Because again, we allow the reaction of creatinine and your alkaline picric acid to completely take place before we measure the presence of the red-orange chromogen form. So, another modification was made wherein we have now that of your Jaffe kinetic na method. Ano yung Jaffe kinetic method? So as what you could see here, the Jaffe reaction will be performed directly on the sample, and the detection of color formation is timed in order to avoid interference of non-creatinine chromogens. So what happens here is that as the reaction takes place, we are simultaneously measuring the color product formed. Okay? So hindi na natin hinihintay na matapos yung reaction before i-measure yung colored na product. But as the reaction progresses, we are simultaneously measuring or detecting color formation. So, of course, it would be an advantage, particularly when it comes to the time that is required to perform the method. And of course, we have here the indirect assays or the enzymatic methods for creatinine measurement. As for the reference method now, for your creatinine determination, the reference method is your IDMS, or this stands for isotope dilution mass spectrometry. So let us now proceed to the next question. Which of the following does not have a significant effect on serum creatinine levels? A. Muscle mass, B. Renal function, C. Protein diet, or letter D. Plasma chromogen. Again, the question asks for the factor which does not have an effect on your serum creatinine levels, particularly if we measure it in the laboratory. So the correct answer for this would be letter C, protein diet, because yung NPN that will be primarily affected by the patient's protein diet will be your blood urea nitrogen, or dot of your bond. Because remember, your BUN is the major excretory product of protein metabolism. So, if the patient has increased protein diet, this would mean that there would also be increased protein metabolism in the body, and increased metabolism would also mean an increased production of its corresponding waste product, which is your BUN. On the other hand, your creatinine will not be affected by the protein diet, since creatinine here comes from the breakdown of creatine phosphate in the muscles. Renal function also have a significant effect on serum creatinine levels. It's because that serum creatinine normally is readily filtered by the kidneys for it to be expelled out of our body, since this is a waste product. So if you have problems with your kidneys, particularly its filtration na function, then of course you expect your serum creatinine levels to accumulate in the circulation, leading to increased levels of your creatinine. What about yung plasma chromogen? Remember how certain substances could cause positive interferences during the Jaffe reaction for creatinine determination. So if there are those substances that causes positive bias or positive interferences, there are also substances which will cause a negative bias or negative interference naman, wherein their presence on the other hand will result to falsely low levels of serum creatinine. And this could be caused by the presence again of your plasma chromogens, which includes that of your bilirubin, and at the same time, that of your hemoglobin. And remember guys that when it comes to muscle mass, this is also the reason why serum creatinine varies depending on gender, on race, and on the age of an individual. So between females and males, males will have higher muscle mass. So we expect that males will have higher creatinine level. So as what I have mentioned earlier, creatinine is the major excretory product of creatine during muscle catabolism. So actually, the creatine here is synthesized by the liver. But creatine will be delivered to the muscle cells wherein it is incorporated with that of your phosphate. So in the liver, creatine is synthesized, but once it's already in the muscles, it is now in the form of creatine phosphate. So since the muscles are involved in certain processes that requires energy, creatine phosphate here is being catabolized, wherein phosphate is released, and thus there is the formation of the excretory product, which is your creatinine. Once present, creatinine will be readily filtered by our kidneys in order for it to be eliminated out of our body. So as what has been mentioned here, creatinine production is constant and it is thoroughly filtered by the kidneys. Because of these characteristics of creatinine, it has been utilized as an indicator of renal function, particularly when it comes to the glomerular filtration function of our kidneys, which is why, diba, we make use of your creatinine clearance. So we have here the formula for our creatinine clearance, that is UV over P. So what does UV over P mean? So it simply means that creatinine clearance is equivalent to urine creatinine, which is expressed in milligrams per DL, times urine volume expressed in milliliters per minute, over by plasma creatinine expressed in milligrams per DL. Proceed with the next question. In the diacetyl monoxide method, what does diacetyl react with to form a yellow product? A. Creatinine. B. Uric acid. C. Urea. Letter D. Ammonia. So of course, we cannot answer creatinine because we have already discussed about the methods for creatinine. So we're left with uric acid, urea, and ammonia. So take note that your diacetyl monoxide method or the DAM method is the direct assay for the determination of your urea. So the correct answer for this question would be letter C. Yung uric acid naman, as we discuss later, this will include the addition of your phosphotungstic acid. And for ammonia, there are two techniques that is associated with its direct assays. So again, we still have the direct and the indirect assay. For the direct assay, again, we make use of the diacetyl monoxide method, and this is also known as that of your Rosenthal method. So what is the reaction in the direct assay? So urea here is allowed to react with the diacetyl monoxide in order to produce that of a yellow diazine. And of course, the absorbance of this colored product will be directly proportional to the level of urea in the patient's serum. Take note guys that this reaction is specifically termed as that of your Fearon reaction. What about the indirect assay? So of course, it will involve the use of certain enzymes. So The enzyme that is utilized for the indirect assay will be that of your urease. So urea, in the presence of water, will be hydrolyzed by urease to ammonium. So urea here will be indirectly determined by either a change in pH or a change in conductivity. So why is there a change in pH or a change in conductivity? So take note, guys, we have here urea as our substrate and ammonium as the product. Between the two, ammonium, of course, is more alkaline. So if urea is present and it was hydrolyzed by urease, there would be a change in pH into a more alkaline na pH since ammonium here is now the final product. Or there could also be a change in conductivity because your ammonium will also have a higher conductivity compared to that of your urea. In other cases, guys, your urea can also be measured indirectly by measuring your ammonia. So later, when we discuss the indirect assay for ammonia, it will involve the enzymatic action of your glutamate dehydrogenase. And actually, pwede na siya magamit yung glutamate dehydrogenase in determining this ammonium that is produced from the hydrolysis of urea. So I think we have here sa next slide yung reaction. Ito siya. So, urea indirect measurement by measuring ammonia. So, again, it begins with the hydrolysis of urea through the action of urease, and there would be the formation of your ammonium. And this ammonium could be allowed to react with your 2-oxoglutarate to be acted upon by your glutarate dehydrogenase. So, aside from these two substrate, we also make use of the coenzyme NADPH. Okay, so as what I have mentioned, we have here your glutamate dehydrogenase, and the product formed will be your glutamate plus water, and the NADPH coenzyme here will be oxidized to NADP. So, of course, very obvious. How do we interpret the level of urea? We interpret it by observing a change in absorbance, particularly a decrease in absorbance at 340 nanometer, since NADPH here has been oxidized to that of your NADP. Next question. When mixed with phosphotungstic acid, what compound causes the reduction of the former to a tungsten blue complex? A. Creatinine, B. Uric acid, C. Urea, D. Ammonia. So, I have mentioned this in the previous question. Again, your uric acid in its direct determination will be allowed to react with that of your phosphotungstic acid. So, the correct answer here would be B. Uric acid. In its direct assay, uric acid determination will be based on the reducing ability of allantoin. Although we have mentioned that uric acid reacts with that of your phosphotungstic acid, but it's not directly get your uric acid. Since what happens here is this, uric acid in the presence of oxygen will be spontaneously converted to allantoin. And as mentioned, allantoin has a reducing ability. So if we'll add that of your phosphotungstic acid, allantoin will reduce it to tungsten blue. And tungsten blue will be then measured spectrophotometrically. So absorbance exhibited by tungsten blue will be directly proportional to the level of uric acid present in the patient's sample. This reaction involved in the direct assay of your uric acid determination naman is called as the Carraway reaction. As for the indirect assay, of course, this will involve enzymes. And for uric acid determination, it will be making use of the enzymatic activity of your uricase. So uric acid level is indirectly determined by either a change in absorbance at 290 nanometer or by a colored product formation. So what happens during uric acid indirect determination? So again, uric acid will be acted upon by the enzyme uricase, converting it to allantoin and hydrogen peroxide. So with this first reaction, pwedeng mo na ma-interpret actually whether there is the presence of uric acid or wala. How do we interpret it? Observe for a change in absorbance at 290 nanometer. Remember that between the two, between your uric acid and allantoin, it is your uric acid that will exhibit an absorbance at 290 nanometer. nanometer. So if it has already been converted to allantoin, there would no longer be absorbance exhibited at 290 nanometer. Or we could further utilize hydrogen peroxide here to be involved in a second reaction wherein hydrogen peroxide together with a dye will be acted upon by your peroxidase in order to form a colored product. Thus, we say that uric acid level is interpreted indirectly by either a change in absorbance at 290 nanometer or by colored product formation. Let's have the next question. Which colorimetric test for ammonia uses dimercuric potassium iodide? A. Berthelot, B. Caraway, C. Glutamate dehydrogenase, or D. Nestlerization. So remember guys that colorimetric test here refers to the direct assays used for ammonia determination. So we exclude na that of your glutamate dehydrogenase since this is an enzymatic assay and not a chemical assay. Caraway is also excluded since we have mentioned that caraway is the term used to refer to the reaction that takes place during the direct determination of uric acid. So we're left with Berthelot and Nestlerization. Take note that these two are both colorimetric tests for ammonia determination, but the one which makes use of the dimercuric potassium iodide as its reagent is the Nestler's method, also known as the Nestlerization reaction. So let's have the direct assay for ammonia determination. Again, we have two. So it's either the Nestlerization or Nestler's method or the Berthelot method. These two differ with the reagents you utilize and at the same time with the colored product that is formed. So for Nestler's method, again, it will make use of your potassium tetraiodоmercurate to produce yellow to orange-brown colored product. Yung range ng color, guys, will signify the level of the ammonia present. If the color produced is yellow, that means that there is a moderate amount of ammonia present in the sample. If it is orange to brown, it will indicate that there is a high level of ammonia in the sample. Next would be that of your Berthelot method. This time, it will make use of your phenol hypochlorite to produce a blue-colored product. And as mentioned earlier, the indirect assay for ammonia determination makes use of the enzymatic activity of glutamate dehydrogenase. So it's the same enzymatic reaction, guys. So ammonium with 2-oxoglutarate and in the presence of the coenzyme NADPH. So this will be converted to glutamate and water with the action of your glutamate dehydrogenase. NADPH is oxidized to NADP, so you have to observe for a decrease in absorbance at 340 nanometer. Let's have the next question. What is the urea concentration if the BUN level is 9 milligrams per DL? So take note of this, guys. Even though BUN and that of your urea are two terms which are used interchangeably, there's actually a difference between these two. When we talk about of BUN, your blood urea nitrogen, this originates from the fact that traditionally, urea is being measured based on its nitrogen content. Thus, it was termed as the BUN testing. However, modifications of these methods were made wherein urea is measured as a whole molecule and not just based on its nitrogen composition. So there's a difference, no, between BUN and urea. Thus, you could be asked to convert your BUN level to urea and vice versa. In the question, we are already given the BUN level which is 9 milligrams per DL and we are asked to convert it into its urea level. So very easy lang, guys. What you have to memorize is the conversion factor. If you are to convert BUN to urea, you simply multiply the BUN level to 2.14. Ito siya. BUN to urea, multiply by 2.14. So, according sa ating question, so that is 2.14 times 9. So, let's see. So, this will be equivalent to 19.26, or if you round that up, this would be equivalent to 19.3 milligrams per DL. So, the correct answer for this question would be letter B. But what if yung question wants you to convert a urea concentration to BUN naman na concentration? Take note ha, you do not divide it by 2.14 but rather you'll have to use another conversion factor. So if it is urea to BUN, you have to multiply the urea level to 0.467. And do not be confused guys ha, because if you go back sa table natin for the conversion of your conventional to SI units, yung conversion factor for BUN is 0.357 as what you could see here. Yung 0.357 is the conversion factor to convert conventional to SI. Okay? Yung 0.467 that is to convert urea to BUN, and then we have 2.14 to convert BUN to urea. So do not be confused no, with the numbers included in our conversion factor. Next question. Azotemia due to decreased blood perfusion to the kidneys is classified as letter A, pre-renal, B, glomerular, C, post-renal, letter D, tubular. So the correct answer for this question, guys, is letter A. That would be pre-renal. So let us explain bakit pre-renal yung naging sagot. So take note of the term azotemia. When we talk about of azotemia, this refers to elevated concentrations of NPNs, specifically that of your urea and creatinine in the blood. This is quite different with the term uremia. Pag sinabing uremia, this also includes the elevation of plasma urea concentration, but the patient will now manifest symptoms of renal failure. And azotemia that is due to decreased blood perfusion or due to decreased blood supply towards the kidneys will be classified as pre-renal. So let's have here the classifications of azotemia. So classification of azotemia will be based on the cause of azotemia. So we have pre-renal, renal, and post-renal. Pre-renal azotemia is primarily caused by reduced blood flow to the kidneys or by increased protein diet catabolism. Remember that your BUN is an excretory product of protein catabolism. So it is but normal that your body tries to eliminate it through delivering that blood towards the kidney to be filtered by kidneys and again eliminated out from the body. So, in the pre-renal azotemia, walang problem yung kidneys. Pero bakit nag-accumulate yung BUN sa circulation? It's because reduced yung amount ng blood supply towards that of your kidney. So kung mababa yung blood flow, that would also mean na hindi masyadong mafi-filter yung dugo through the kidneys. So that's why nag-accumulate yung BUN kahit wala namang problem with the filtration function of your kidneys. Or it could be because by increased protein diet or catabolism. So if you have high protein diet such as high meat diet or certain condition that leads to increased protein catabolism, of course, as what we have mentioned, tataas din yung production ng ating waste product, which in this case is your BUN. So the conditions associated with pre-renal azotemia stated here includes your congestive heart failure, your shock, hemorrhage, and dehydration. The first three is associated with reduced blood perfusion towards the kidneys. And then, of course, if you also have increased protein catabolism and high protein diet. Next, what about yung renal azotemia? So, very obvious naman, the problem is with your kidneys. So, there is decreased renal function resulting to a compromised urea excretion. So, if your kidneys are damaged, it will no longer be capable of performing its job of filtering plasma and eliminating waste products such as that of your BUN. So what happens is that BUN is no longer eliminated from the body. So it stays inside the body and it accumulates at a high concentration in the body. So of course, conditions associated with renal azotemia include acute and chronic renal failure, renal diseases including glomerular nephritis, and tubular necrosis. And then the last azotemia classification is the post-renal azotemia. This time, there's also no problem with the functions of your kidneys. But the urinary tract could not completely eliminate your BUN because there is an obstruction of urine flow. Again, as stated here, post-renal azotemia is caused or is associated with the obstruction of urine flow anywhere in the urinary tract, particularly the lower urinary tract. So, condition associated would be, of course, your urinary tract obstruction, which could be because of certain tumors or renal stones. Let's proceed with the next question. A high BUN creatinine ratio with a significantly elevated creatinine is usually seen in letter A, post-renal azotemia, B, liver disease, C, pregnancy, or letter D, low protein intake. So remember guys, diba, that we have mentioned your creatinine is considered as a good indicator of renal function. Usually, if the patient is suspected to have renal problems, one of the tests requested would be your creatinine, and it would usually be accompanied with testing for the BUN level. And the determination of the ratio between your BUN and creatinine would be of great help in specifically identifying what is the problem with the patient's kidney. So there would be actually 4 interpretations with regards to the value of your BC ratio and at the same time its relation with the BUN and creatinine levels. But in the question, the high BC ratio with high creatinine, this is usually seen in the post-renal azotemia. On the other hand, your liver disease, pregnancy, and low protein intake will be associated with a low BC ratio. So what is this BC ratio? So it simply refers to the ratio between that of your BUN and creatinine. And as what I have mentioned, it is used to aid in the differentiation of the specific cause of abnormal BUN concentration or the diagnosis of the specific problem with the patient's kidney. Remember that the normal BC ratio ranges from 10 to 20 is to 1. So that means to say, guys, that under normal condition, BUN concentration is higher by 10 to 20 times compared to that of the creatinine concentration. The reason behind this is that even though both your BUN and creatinine are filtered and excreted out of the body through the kidneys, 40% of your BUN are normally reabsorbed by the kidneys back to the circulation, compared to creatinine wherein a very small percentage lang of this NPN is being reabsorbed. So back to the BC ratio, remember guys that even though both your BUN and creatinine has an effect with the value of your BC ratio, it is BUN which will exhibit a greater effect. So we have here your BUN and that of your crea equivalent to the BC ratio. So what I mean by this is that if there is an increase in the value of the BC ratio, this will be most likely because there was an increase in your BUN. And then we interpret the values of your creatinine in order to differentiate the causes why BUN is increased in this case. And in the same way, when the BC ratio is low, this is primarily because the BUN level is also low. So again, between BUN and crea, it is your BUN that will have a greater effect with that of the BC ratio. And usually, kung taas ang BC ratio as caused by increased BUN, we have to check the creatinine level so as to differentiate the causes nga ang nagsaka ang aton nga BUN. Anong problem sa kidneys? Or if wala problem sa kidneys, diin ang problem. Okay? So, diri na di dayon masulod ang interpretation ta with our BC ratio. So, the first result here would be a low BC ratio. So, lower than 10 to 20 is to 1. So, as what I've mentioned, since the BC ratio is primarily affected by BUN, a low BC ratio is primarily because there is low BUN level. So, conditions that results to low BC ratio includes those conditions resulting to low BUN levels. So, this decreases in cases of decreased protein diet, liver diseases, pregnancy, infancy, and acute tubular necrosis. The second result with your BC ratio is a high BC ratio but normal yung creatinine. So of course, the high BC ratio here is primarily because of an increase in the BUN level. But take note ha, normal pa yung creatinine. So this means to say na wala problem or wala pang problem with the kidneys, which is why a high BC ratio with normal creatinine is most likely because of pre-renal azotemia. Okay? And ano nga yung causes ng pre-renal azotemia natin? It could be either because of low blood supply to the kidneys, high protein diet, or increased protein catabolism. The third BC ratio result to be interpreted here is a high BC ratio with increased creatinine. So, high BC ratio, again, this is because of an increased BUN. But this time, mataas rin yung creatinine. So, this could be explained first with the presence of post-renal azotemia, or that means there is obstruction or occlusion of the urine flow along the lower urinary tract. So, nagtaas ang imo nga BUN kay waay siya na completely pagwa sang imo nga kidneys, which is the reason why ma-increase man ang imo nga creatinine. Because of course, all substances nga ginfilter ni kidney, hindi ka na mapagwa kung may post-renal azotemia since there is occlusion. So, which is why high BC ratio with increased creatinine could be because of post-renal azotemia. Or, this could also be an indication for a pre-renal azotemia accompanied by an underlying renal disease. And the last BC ratio result to be interpreted is this one. Normal BC ratio with increased BUN and creatinine, which indicates renal azotemia, or the problem is with the kidneys na nga. So, the kidneys are not capable of performing its normal function, particularly with that of filtration. And miss, bakit increase si BUN but the BC ratio here is normal? Remember guys, yung problem is with the kidneys na. So of course, NPNs, including that of your BUN and creatinine, will not be eliminated out of the body and starts to accumulate in the circulation. In this case, BUN and creatinine increases or accumulates at the same rate, which is why if you get their ratio, parang within normal pa rin yung grades niya. But you'll know that there's a problem because individually, their concentrations are very high. Next question. The most important patient preparation for ammonia analysis is the avoidance of A. Smoking, B. Protein-rich diet, C. Alcohol, D. Exercise. So the most important patient preparation when it comes to ammonia analysis is that the patient should not smoke for several hours before ammonia analysis. Yung sa letter B, yung protein-rich diet, so, of course, this is important naman when it comes to BUN analysis. Kasi nga, BUN levels will be affected by protein-rich diet. Alcohol, on the other hand, will greatly affect the levels of your uric acid because presence of alcohol increases purine catabolism, which leads to the production of your uric acid. And exercise naman, on the other hand, will affect the level of our creatinine. So for the patient and sample preparation for ammonia testing, again, cigarette smoking by the patient is a significant source of ammonia contamination, which is why it is recommended that patients do not smoke for several hours before the sample is collected. Aside from smoking, the presence of urine and ammonia in reagents, detergents, and glassware could also be a source of ammonia contamination. Thus, these things should also be avoided before ammonia testing. So, suitable anticoagulants for blood to be collected for ammonia testing would be heparin and EDTA. And also, guys, take note that ammonia testing requires the samples to be chilled. So, samples should be centrifuged at 0 to 4 degrees Celsius within 20 minutes of collection, and the plasma or the serum shall be immediately removed in order to avoid hemolysis. Specimens should be assayed as soon as possible, but if not, it should be frozen at negative 20 degrees Celsius. And as I have mentioned a while ago, hemolysis must be avoided since our red blood cells contains 3 times more of ammonia compared to the extracellular fluid. So we're now down to the last question. So we have here a serum creatinine of 6.6 milligrams per DL correlates with which of the following findings? A. Urea nitrogen is equivalent to 85 milligrams per DL. B. Urea nitrogen equivalent to 10 milligrams per DL. C. Urea nitrogen equivalent to 15 milligrams per DL. Or D. A BC ratio equivalent to 9. So before we could correlate the creatinine value, let's first identify if this value is normal or if it is higher or lower than normal. Remember, for serum creatinine, guys, yung approximate na normal value would be 1 to 1.5 milligrams per DL. But as what I have mentioned, it varies with gender. But approximately, let's just use yung 1 to 1.5 milligrams per DL na normal value ni creatinine. And also, we have here yung normal concentration of other NPNs such as that of your BUN, uric acid, and ammonia. So now that we know the normal value of your creatinine, we interpret that 6.6 milligrams per DL is high creatinine value. Okay? So that's the first interpretation natin. The patient has high creatinine. And if you go back with the BC ratio na results, remember that your high creatinine could either accompany a high BCR ratio. Again, it could either accompany a high BCR ratio or a normal BCR ratio. So the next step here is to identify, based on the question and at the same time sa choices, the 6.6 milligrams per DL na serum creatinine, which is very high, is most likely to be associated with. So let's check each choices. So for letter D, BC ratio is 9. So remember, the BC ratio is 10 to 20 is to 1. So 9 means that this is a low BCR. So go back tayo again dito. High crea could either be accompanied by high BCR or normal BCR. So letter D is not the correct answer since this is low BCR na value. Next, what about choice C? Urea nitrogen is equivalent to 15 milligrams per DL. So 15 milligrams per DL na urea nitrogen is within normal since yung normal level natin is 6 to 20 milligrams per DL. That means letter C here is normal yung ating BUN. Now, normal BUN is not seen in either high BCR or normal BCR. Kasi nga 'di ba, yung high BCR natin should be indicating high BUN level. And yung normal BCR, this is accompanied by high BUN and high crea. So hindi pwede na normal yung ating BUN. So C is also excluded. What about letter B? Urea nitrogen is 10 milligrams per DL. That is still within the normal level of your BUN and it is not likely to be associated with high creatinine. So the best answer here would be letter A. The urea nitrogen is most likely 85 milligrams per DL. Now, let us identify if the level of serum creatinine that is 6.6 milligrams per DL is associated with urea nitrogen that is 85 milligrams per DL, what would be the BCR ratio? Would it be high or would it be normal? So to solve for that, so we have here your BUN, which is 85, and then we have our creatinine, which is 6.6. So we simply divide both sides by 6.6. So 85 divided by 6.6 is equivalent to 12.8, or to round that up, that is equivalent to 13. And of course, 6.6 divided by 6.6 is 1. So our BCR ratio is 13 is to 1, which is within the normal range that is 10 to 20 is to 1. So how do we interpret the creatinine level here, the urea nitrogen, and the ratio between the BUN and creatinine? So we interpret it as normal BCR accompanied by high BUN and high creatinine, which indicates that the increase in the NPNs is because of renal azotemia.